Hi everyone, welcome back to my AP Calculus class. This is the last my video before 2020 AP exam. Today is May 6th, and then next Tuesday you will take AP exam. So I'm gonna explain only one problem, free response questions, 2019 AP Calculus BC free response question, number 4. Let's just start. There is a cylindrical barrel with a diameter of 2 feet. Okay, diameter is 2 feet. 2 feet contains collected rainwater as shown in the figure above. The water drains out through valve at the bottom of the barrel. The rate of change of height h on the water's barrel with respect to time is modeled by this. dh over dt is negative 1 over 10 square root of h. It is kind of negative. The rate should be negative. That means that amount of water is decreasing, reducing now, right? It's draining, that's why. So h is measured in the feet, and then t is measured in second, and then volume of the cylinder is pi r squared h. Then find the rate of change. Find the rate of change of volume of water in the barrel with respect to time when the height of the water is 4 feet. 4 feet. So it's a really rate of problem because that radius of that base circle is 1 because diameter is 2. That means r is 1 foot. It is not changed. It's a fixed number. So the volume was pi r squared h, but r equals 1. That means volume is pi h. And then just find the derivative using implicit differentiation. So 1v's derivative is 1, and then dv equals pi h's derivative is just pi times dh, and divide both sides by dt. Got it, right? So when height is 4 feet, that means when h is 4, if h is 4, what is dh over dt course? dh over dt is equal to negative 1 over 10. Formula is here, right? So square root of h. So h is 4. So it is negative 2 over 10, negative 1 over 5. Use this number for dh over dt, and then you're gonna find what? dv over dt, which is negative pi over 5. That's the volume, rate of change of the volume per second, right? So it's cubic feet per second. Cubic feet per second. That's a unit of rate of change of volume. So A is done. So how found it? Because h is 4, we found dh over dt first, right? Plug in 4 into this function. There was negative 1 over 5. And then find over dv over dt. Which formula is that? Here it is pi times dh over dt. So negative pi over 5 cubic feet per second. That's the first question's answer. B, when the height of the water is 3 feet, that means when h equals 3. When h equals 3, rate of change of height. Rate of change of height. What does it mean? That's dh over dt, right? What is dh over dt? dh over dt is given. That function negative 1 over 10 square root of h. That function, the function is increasing or decreasing. If fx is increasing, then f prime of x is less than 0, right? And then fx is decreasing, then first derivative function, f prime of x is less than 0, right? No, I'm sorry, that is greater than 0. What? Okay, if fx is increasing, derivative function is greater than 0. fx is decreasing, derivative function is less than by first derivative test. But it asks you dh over dt, rate of change, that function is increasing or decreasing. So we have to check that function negative 1 over 10 root h's derivative, right? Because this function, now original function, we have to check this dh over dt is increasing or decreasing, rate of change of height, rate of change, that means derivative, right? The h over dt is decreasing or increasing. To know that, find that negative 1 over 10 square root h, this function's derivative, right? Because I have to find that whether that function, negative 1/10 square root h, increasing or decreasing. That's why we have to find derivative of that function. So that is equal to negative 1 times the coefficient. Square root x prime is 1 over 2 square root x by power. So 1 over 2 radical h. When h equals 3, right? It says when h equals 3, and then plug in 3 for h, 3. So negative 1 over 10 times 1 over 2 root 3. This is less than 0, right? This is less than 0. Because this derivative function is less than 0, rate of change of the height is decreasing. So answer is what? Decreasing. That makes sense, right? Let's go to C. At time t equals 0 second, height of water was 5 feet. So use separation of variables to find the expression h in terms of x. Just to solve this differential equation. So I rewrite the differential equation over here. dh over dt is equal to negative 1 over 10 times square root of h. I'm going to use separation. I'm going to multiply by dt both sides first. It'll be good. And then I'm going to divide by square root of h both sides. So 1 over radical h dh is equal to negative 1 over 10 dt. That makes sense, right? And then put integral both sides. What is the integral of 1 over radical h? That is h to the negative 1/2 powers, right? That integral dh is equal to 1 over negative 1/2 plus 1, this is 2 h to the negative 1/2 plus 1/2 powers, 2 root 2h. 2 root h. Got it, right? That is equal to, what is the integral negative 1 over 10 dt? That times t. Plus c. Now we have no idea how to find the c, but we know, initial height of water was 5 feet. At time t equals 0, height of water is 5 feet. That means when t equals 0, h is 5. So plug in those numbers, 0 for t and 5 for h. So 2 root 2 5. That equal to c. Okay, so we got the value of c, 2 root 2 5. So I'm plugging this number for c, and you can find that 2 square root of h equals negative t over 10 plus 2 root 5. And then solve for h, right? So divide by 2 first. So square root of h equals, divided by 2, negative t over 20 plus square root of 5. So what is h equals? That whole thing's squared. Got it? So h equals this, negative t over 20 plus radical 5 whole things squared. This is the answer. Okay, so usually in the AP exam, the y over dx or the h over dt is given, and they can ask you a lot of things. They can ask you second derivative, right? Second derivative about d square h over dt square. You have to find it, right? Derivative of derivative function. Or sometimes they ask you slope field. They ask you just solve that equation by separation, something like that, and then they can ask you real radiated problem. Okay. All right, I solved one problem 90 AP Calculus BC free response question. And then I really hope you, everybody, can take next week, next Tuesday, AP exam very well. Thank you so much for watching my video. Then please click subscribe and like and turn on notification. And then this video will be the last video in this semester. Now you're gonna learn limit and then derivative and application of derivative. I'll keep teaching that part after summer. So I'll be back after summer. Okay, have a good summer. Thank you so much again. Bye-bye.